go ahead and pause you there, and let's just share our ideas, right? All the ones that we've come up with. And hopefully by doing that, we can learn from each other, right? You might only have one method right now, but maybe after we share, you'll have 2, 3, 4, however many, all right? So let's start out with Lily. Will you show us your first method, please? Should show up pretty quickly. And then you can kind of come up here and point like.
Okay, so volume is just length times width times height. So since they're cubes, those are all going to be the same. So the first square was 4 by 4 by 4, which equals 64. And then square 2 was 1 by 1 by 1, which equals 1. And since the little one was inside the big one, you just subtract the 1 from the 64 and the 63.
How many of us did it that way? Okay, that might have been our first method. Okay. All right. So you can see here that we're, again, we talked about the volume of a cube last week. Length times width times height. In this case, it's a cube, so it's just the side length cubed for both of these. Gives us 64 for the volume of the outer cube, 1 for the volume of the inner cube, and then the difference of the two. Right? All right. Thank you very much. Love the golf clap. All right. Up next, Corlo, will you show us your method, please? I think maybe the last one that you did.
Okay, so I forget what this method is called, but I saw that to find the volume you have to cube the length. So 4 cubed minus 1 cubed was 63. And I remembered that the one factorization method we did was where we take the cube root of them and put them in the first parentheses, so 4 minus 1. And then in the second parentheses, you do the first number squared and then the opposite sign, and then the two multiplied by each other, and then always positive, and then the last number or squared. And then so 4 minus 1 was 3, and 16 plus 4 plus 1 is 21, and 3 times 21 is 63.
Okay, so what method is she using here? Difference of 2 cubes. So, wait a second, if we go back to the picture, what are we doing? We're finding the difference of the 2 cubes, right? Which is the visual way of seeing the difference of 2 cubes formula. Right, that we've studied before, but now we're seeing it visually connected to geometry as we're doing it in class, as we talked about the volume last week. But now we see it here, the difference of 2 cubes. And we get the same answer, isn't that cool? Right? Doing that, now, it is a little bit drawn out, right? We wouldn't probably do that if we were just calculating, but we thought about all the ways we could do it, and this is just one of those ways, right? So we can learn from that. All right? Thank you very much. All right, so one more that I want to bring up is like a visual approach to this. Ashley, will you kind of tell us what you were doing initially?
Well, I couldn't necessarily get it to work, but I had the cube, and so I put like the one small cube on the very corner of it, and I was labeling like the side lengths of each. So like where the one cube was off, you would have like 3. Then all the other cube, like the other side would still be the 4. So I labeled each of the side lengths.
And you were gonna basically cut it into pieces, right? And find the volume of this piece, the volume of that piece, and the volume of this piece. You may not have had time to get that far, but that's one way to do it, split it up into those pieces, right? One other one I want to show you is another student from first period. I want to see if you can figure out what they did here. All right, let's see if we can figure out. Ellie, can you explain this student's work?
Well, do the difference of squares formula to like kind of work it backwards, and like since 64 and one of the squares, other squares, that you can like factor it out.
Yeah, right? Difference of two squares, a plus b, a minus b. So you get 9 times 7 is still 63, right? Now, would this method work every time? No, it just so happens the numbers I picked resulted in both of the numbers being cubes and squares, but they won't always be perfect squares, right? And so this is just one thing that they noticed. They're like, oh, the two numbers I got were perfect squares, so I can rewrite it that way. All right? Any other questions about this task? All right, so hopefully we've learned how to connect the difference of two cubes formula to a visual approach, a visual problem at least, but also you can see how it ties in the difference of two squares as well. All right.